Hi, everyone. So today we're going to cover optimization problems, one of the biggest and most important ideas in our calculus class. So what we're going to try to do is find the optimal solution to a certain application or problem. So I've got a little strategy written here on the in front of you. And so we're going to try to follow this, of course, always starting with reading the problem. Probably don't have to mention that. Figuring out what variable we're going to use for our problem. Figuring out if there's a reasonable domain, like should we be talking about only positive values, or what kind of values make sense for the variable that we're looking at. And then write an equation. Now, this can be the hardest thing to do in these optimization problems. However, for the first few of the problems, I think we're going to do the equation is many times given to us. And then once we get that equation and know what we're going to optimize, know what we're going to maximize or minimize, then we follow our normal steps of finding the optimal value. And so step 5, this is the key here. We go through those steps, which means finding the critical point, right? Using the first or the second derivative test to figure out if we have a min or max. And then at the end, plugging the critical value back into the correct equation to get the answer to the question. And then don't forget this part, actually answering the question in a sentence with the correct units. Okay, so all these steps are steps that are essential for you to be successful in finding these optimal values. Also, put a little list here of formulas that we might need. So just to remind you of those, and so you have them. Occasionally, we need a geometry formula, which I'll give to you, but I think on most of ours, the applications are business, and so we probably won't need too many of those if we do. All right, let's jump in. So there are a lot of examples in this particular section. I'm only going to do 3 of them in this video. And then the next video, if you want to see more, I'll do about 3 more. But I think these first 3 ought to give you the tools you need to get through most of the problems. Okay. All right, so let's look at this first one. We're given a cost function and a demand function. Find the production level that will maximize profit. Okay, so if we're trying to maximize profit, whatever it is that you're asked to maximize or minimize, that is what you need an equation for. So the first thing I'll need is a profit equation. Okay, so I have a cost function and I have a price function. That's not a profit function, that's a price function. So I can get profit. Remember our formula, we can get profit by revenue minus cost. So I can get the revenue because I have the price function. Revenue is always quantity, so X multiplied by our price. So in this case, 1740. All right, so I have a revenue function, I have a cost function. Let's get our profit function, and then we will be off to the races here. So I've got 1740X minus our cost. Again, don't forget the parentheses, because you're going to be distributing the negative. All right, so revenue minus cost here, distribute the negative, combine some like terms, and get yourself a profit function. All right, now I'm going to rearrange, put it kind of in descending order. So again, if you do that, you'll get a negative 0.4x squared. Adding your like terms, the x terms, looks like a 1160x. And then minus an 8350. All right, so there's our profit function. Now, let's make sure we're clear on what our variable is. So in this particular problem, X must represent our units. Now, they didn't say what these units were, but let's make sure we know that that's what X is. And so if X represents units, reasonable for the domain would be that we would only have positive units that we produce and sell. So just keeping in mind that we're going to just be talking about positive X values, right? Okay, so let's go through our steps of optimizing, which would be starting with, let's get the critical point. Let's set that critical, not set the critical, sorry. Let's get the derivative to get our critical point, and then we'll set that equal to 0. All right, let's go. All right, P prime of X let's see, 2 times negative 0.4, negative 0.8x. And then the derivative of 1160x is just 1160. Let's set that equal to 0. Again, I encourage you to pause this and do this yourself so that way you're not just, watching me and doing it. It doesn't help as much as you doing it yourself and then checking it, right? So again, you have to do this work yourself and not just follow what I do. It's much easier to learn something when you're the doer. All right, so I come across with an X value of it looks like when I divide this 1450. Again, use your calculator, type that in. So this would be my critical point. I cannot assume that this is the answer to the question. I have to prove it. So I need to prove that this critical point is the one that will maximize the profit. So you have your choice of either doing a first derivative test or a second derivative test. And I think here, a second derivative test would be real easy. So let me get a second derivative real quick. So let's take a look. Here's our first derivative back here. Let's get the derivative of that. So P double prime would be negative 0.8. Okay, that's nice. So if the second derivative is negative 0.8 or negative all the time, well, that really helps me. If the second derivative is negative, that means that the graph is always concave down looking. And if the graph is always concave down looking, then I can guarantee that that critical point that I have must be a max. Great, I have proven what I wanted. Let's just now figure out the answer to the question. It says, find the production level that will maximize profit. So production level is the units. All right, I have my answer then. I don't need to plug back in anywhere. It's just asking for the production level. So here's my words. The production level of 1450 units will maximize the profit. And that's all they asked for. Now, if they asked for what's the maximum profit, well, then I'd plug my X value into the profit function and find it. So this case, though, they only asked one basic question, so I've got it. Here's my answer. So again, just a reminder that this is really key. You have to do this test to prove your critical point is either a max or a min. I chose the second derivative test. Maybe the next problem I'll do the first derivative test to demonstrate both. Okay, one down, 2 to go. Let's try our next one here. So number 2 actually gives us a profit function when X units of a certain product are sold. Okay, find each. Now it's got a lot of things to find here, 5 of them. So I have a feeling we're going to be doing a lot of different steps here. This is a really kind of complex problem. Okay, so step 1, it says find the profit when 75 units are sold. Okay, so this is not anything about a derivative. This is just, hey, get the profit. So, well, if you want profit, you plug in the profit function. So I'm just going to take 75 and plug it into that profit function. So this is just a kind of plug and chug situation. Just you using your calculator and getting the answer. All right, so plug that in, get your value, and then, write a little sentence with that. So if you plug 75 into that profit function, here's what I get, and you should double check. I'm looking at about 37,906. Now remember, because this is money, we always keep 2 decimal places unless they say otherwise. So this comes out to 0.25. Okay, so I'm going to write a quick little sentence here. The profit when selling 75 units is, and then I give my answer, 37,906.25. Okay, so I'm expecting those little sentences in your answers. Okay, so that's our profit. The part B is asking you for the average profit. Okay, average profit is like a profit per unit. So what I can do, and I've got most of the information I need already, is just take that total profit for 75 units and divide by 75. And that will give me the profit per unit. That gives me the average profit. So I believe I put an average formula up here. If you look up here, average profit here, P of X over X. So you take the profit at your X value and divide it by your X value. Okay, so that's what I'm going to be doing here. Now I already did the profit for it. I did that in part A. So what I'm doing is I'm taking the profit at 75 and dividing by 75. Okay, so I already have the profit at 75. I did that in part A. So I just have to take that number and divide by 75 units, and then I will get a profit per unit. Okay. All right, so let's divide that. And again, this is money. So 2 decimal places. So I'm going to get a number, and this is dollars. I've come up with 505 and then a 42 cents. And this would be per unit. Okay, per unit now, because the profit on the top is dollars, and on the bottom here, these are units. So it's dollars per unit. All right. So then again, we can write our little answer. The average profit in dollars per unit is this. Okay. All right. Well, let's see. What's our next question? Part C says, what's the rate that the profit is changing when exactly 75 units are sold? Okay. Now, when you see the word rate, I'm hoping you're thinking derivative, because that's what the derivative gives you. It's the rate of change. So, all right, what this is really asking you here, what's the rate the profit's changing? So I'm looking for the derivative of the profit at 75. So first I have to start with getting the derivative, and then I will plug in 75. And then I've got my answer. I'll know whether the profit's going up at 75 units, and I'll know if the profit's going down when I sell 75 units, okay? All right, so let's start with our derivative. So let's get P prime. Let's get our rate of change of our profit function. So take your profit function and do the derivative. So let's see. 2 times negative 1.75 is negative 3.5, and then lower it by 1, so it'd be x. And then the derivative of 750x is 750. Okay, there's our derivative of our profit function. And then we are going to plug in to that derivative 75. Because it wants, how is it changing when we sell 75 units? So plugging 75 in here. And then what we're going to get here, it's a rate of change. So it will be dollars because it's profit, and then units because we're putting in units. So it's dollars per unit. So let's see, what do we get? If we plug this in here, looks like in dollars per unit, 487.50 per unit. Okay, so I'm going to put this in words so that you're sure and clear what this is telling you. So this number, this 487.50, is telling you how the profit is changing. So let's do this. I'm going to say the profit is increasing at a rate, right? This is a rate of, and then give my dollars, $487.50 per unit when 75 are sold. Okay, so that's the good news because that means your profit is going up. So when you're selling 75 units, your profit is still increasing, and it's increasing pretty fast, almost $500 every unit. Your profit's going up. So that's good news, right? That's good. Okay, so that's our derivative at 75. And again, you see how I could tell to do the derivative is that word rate. Now, part D uses the word rate also, but they say get the rate that the profit is changing on average. This is different. This is an average rate of change. This is just a good old-fashioned slope, not a derivative, because a derivative is an instant rate of change. So for part D, we need to just do a regular old slope on this thing, average rate of change. Okay, so let me bring this down here. So what we're looking for here is the average rate of change. This is what we did back in, section 1.3, I want to say, just finding the slope. And so we're going to get the average rate of change on, let's see, 75 to 150. So from X is 75 to X is 150. So this is like the first X value and the second X value. So we're just needing a slope. Okay, so remember slope, y minus y over x minus x. So you're going to have to find the y values that go with these x values. And I say y values, they're really p values, they're really profit values, right? So what you have to do is you need to get the profit at 150, subtract from that the profit at 75, which I think I already got, and divide that by 150 minus 75. Okay. Now we already did the profit at 75. That was actually the answer to part A. So we just need to get the profit at 150, plug 150 into the profit function. So, pause the video here and get those numbers and then come back and then let's check our numbers and see if we're getting the same thing. See if you're plugging it in the right places. Okay. Okay, let's look at your numbers. So when you plugged 150 into the profit function, you should get this 64,000 minus when you plug 75 in, we already had that number. And then you divide, right? You subtract them, divide them. I probably would just type it all in my calculator at once. And then you end up with this number down here for our average rate of change. So notice it's a positive number. So that's just telling you that when you sell from 75 units to 150 units, on average, the profit's going up 356.25 a unit. Okay, so that's a good news thing. Profit is increasing. So I'm going to put just some words here. So I'm going to say profit increases, and then you have to use the word average. On average, okay, because this is an average rate of change. So 356.25 per unit, okay, when selling 75 to 150 units. Okay. Yeah, I know that's time consuming. So again, the key is trying to read the question and figure out what does it want. And so my keywords here was it asked me for the rate and it said average. So I'm looking for the average rate of change. Okay. All right, we got one last one. Part E. Part E says, figure out the number of units sold when the profit stops increasing and starts decreasing. Yeah, so far what we've noticed here by both of the rates we've figured out is that the profit's definitely been going up and definitely increasing rather rapidly. So I wonder, when does this profit stop increasing? When does it start decreasing? Well, what they're asking you for, if you envision this, so it's increasing, right? Here's our profit going up, and then it starts to decrease. Well, that's just asking you to find the max, right? Isn't that what we're looking for here is the max? When does it stop increasing and begin to decrease? Well, that's when it hits the max. All right, so part E, just in disguise, is really saying to you, find the maximum. Okay, now we did find the derivative earlier, so let's take that derivative, our p prime, and that was what, negative 3.5x plus 750. Let's set that equal to 0 and get our critical number, because our critical number most likely is our max. So setting that equal to 0 and solving. All right, so anywhere our derivative is 0 is usually a high point or a low point We're just going to figure out which this is. All right, do a little solving. Divide by our 3.5 here. And it did say something about rounding to a whole number. So let's see what we get. It says round to the whole number if necessary. Yeah, I believe so. Let me get my calculator. So if I take 750 and divide that by 3.5, yeah, I get like 214.2. So let's just say, I'll put a little squiggly equal here. Let's say it's about 214. Okay, these are units. Now let's just double check and make sure by a little derivative test that this 214 is actually where the increasing begins to decrease. Okay, so let's pick a couple of points, one on the left of 214, maybe 1. Pick something on the right of 214, I don't know, maybe 300. Let's put them into the derivative. Remember, we're doing a derivative test and see what's happening. Okay, so if you plug 1 into your derivative, negative 3.5 times 1 is negative 3.5 plus 750. Oh, that's definitely a positive number. So I can definitely see, and you probably already knew from earlier, that on the left side of 214, our profit's going up. Now, if we plug 300 into our profit function, or I'm sorry, our profit's derivative, negative 3.5, you multiply it by 300 and you add 750. That comes out negative, which tells me that on the other side of 214, our profit begins to decrease. Okay, 214 is the number they're asking for because they said find the number of units where the profit stops increasing, starts to decrease. Here it is. So this is our answer. So let's kind of put it in words here. At, I'll say about, because I did round off, 214 units, profit stops increasing and begins to decrease. So I just, use their words back at them. And begins to decrease. Right? So when you answer these questions, it's really helpful to just take the words in the question and give them back as the answer. Right? Okay, wow. So that was pretty intensive. That had a lot of information in it. I know there's a lot there. And, going over it again certainly will help. All right, let's try one more. Let's squeeze one more in. So I'm going to skip and try number 4 here. All right, so like I said, we're not going to be able to kind of get all these examples in, but I want to at least do 3 good ones, and then I'll do 3 more on the next video, which you can decide if you need to watch that as well. But the process will, kind of stay the same. All right, let's take a look at number 4. It's giving you a cost function. And it says, find the production level that will give you the minimum for the average cost. Okay, so we're trying to get the minimum for the average cost. Okay, be careful now. It's not the minimum cost. It's the minimum for the average cost. So what I need in order to do this problem is I need an average cost function. Right? Whatever you're trying to minimize or maximize, that's the function you work with. So the first thing I need to do is find an average cost function. Okay, now if you look back at those formulas I gave you before, if you want to find average cost, I'll abbreviate AC of X. All you do is take your cost function and divide it by X. That's how you get an average cost function. So that's the function I need to get to do my work on, to do my derivative of, and so on like that. Okay, so let's get average cost. So average cost of this would be take your cost function, 4,400, and divide by X. Now, when I divide by X, I'm going to individually divide each one by X. It'll work out nicer. I mean, if you do one big divide by X, that's fine. But then for me to get the derivative gets a little messy. So I'm going to do this. I'm going to just take each term individually and divide by X. And the good thing is if I do that, there's some definite reducing that I can do for my average cost function. Okay. So again, I'm the only thing I'm trying to do now is get the function that I'm going to use to optimize. So let me write my average cost function, AC of X. So now this term here, this 48,400 over X, because I know I have to do the derivative of it soon, let's write it this way, 48,400 X to the -1. Let's bring that X up. All right, and then this, the second term here, let's just cancel the X's. So that will just be what, 400. So that's great. And then of course, the last term, X squared divided by X, that's just X. Okay, I am ready to do the work now. So I have my average cost function and I'm trying to minimize it, get the lowest. Okay, so we start by, let's find our critical point and then go through that whole process. All right, to get our critical point, we take our derivative and set the derivative equal to 0. So here goes, average cost prime of X, so the derivative. Let's see, -1 times this 48,400 X, and if I lower that by 1, -1 minus 1 is -2. The derivative of 400 is 0, and the derivative of X is 1. All right, let's set this equal to 0. And because I'm going to have to solve this, I'm going to take this X to the -2. Let's just throw it underneath. So let's write it this way. -48,400 over X squared plus 1. Set that equal to 0. Let's do some solving. To solve that, let's get rid of our fractions. So let's take and multiply by the LCD on both sides of the equal sign. Everybody multiplies by X squared, right? So if I do that, X squared times 0 is still 0. X squared times the -48,400 over X squared, well, X squareds cancel. Get -48,400. And X squared times 1 is X squared. So it cleans it up very nicely, right? So this X squared just distributed into everybody there. Let's put the 48,400 on the other side of the equation, equals X squared. And let's take our square root and hope it comes out nice. I don't know if it does. And don't forget, there is a plus or minus when I do a square root. However, on this particular problem, X should be a positive number only because X stands for our units, okay? All right, so X is going to equal, again, it would be a positive or negative, but I will throw out the negative. It does come out nice. Square root is 220. Okay, so the critical point is 220. Now, is this a minimum or a maximum? I need to prove. You can't assume. So, gosh, I think for this, I'll just do a first derivative test because I think the second derivative might be a little messy. So let's just do a first derivative test. And let's just make sure that our critical point is the point we want. So I'm going to put a little number line here. Let's label it the first derivative, AC prime. Let's put our 220 on it. Let's pick a point on each side of our 220 and put it into our derivative. Remember our derivative back up here. So I don't know, let's pick an easy point. We could plug in 1 on this side. We can't plug in 0 because 0 would make it undefined. But we could plug in 1 and then pick something bigger than 220, I don't know, 300, something like that. So plug those into your first derivative and see whether you get a positive value or a negative value, okay? So if I plug 1 in my first derivative, I basically end up with -48,400 plus 1. That's definitely going to be negative here. That's negative. That's a decreasing. That tells me my average cost is going down there. Now, if you plug 300 in, again, use your calculator to do this work. 300 into the -2 plus 1. That's going to turn out to be a positive. So we get a positive value here, which tells me average cost at this point is going back up. Okay, so if it's coming down, turns around at 220, goes back up, that tells me, okay, great. My 220 is definitely the minimum. And that's what I wanted, right? Okay, let's go back here and let's see what the questions were so I know that I answer them. So one question was, find the production level that will minimize your average cost. So that's the 220, right? Because the 220 is the units, and that's the production level. Then it says, well, what is the minimum average cost? So that I have to do a little bit more work for. Okay, so let's put our answer. So the answer for part A is that 220 units will minimize the average cost. Now, what is the minimum average cost? Okay, let's take our 220 and put it back into the average cost function, right? Into average cost. So I want to know, what is that lowest average cost? So way back to the average cost function, remember? So that's going to be 48,400 basically over 220 plus 400 plus 220. All right, just plug those in the average cost function, not the derivative, right? And if you plug those in there, what I came up with is 840. Now remember, that's an average cost. So that's a dollar amount per unit. So when I give the answer, I want to make sure I say dollars per unit. Okay, so here's the answer to part B. The minimum average cost is $840 per unit. Okay. So this one I did have to actually take my critical point and plug back in to get the answers that they wanted. Okay, well, I hope this has been helpful. Again, I'll do a few more in the next video if you need them. And, you know, it's certainly always a good idea to watch more examples than less. But if you're good to go, you're good to go. All right, until the next video.